So in the second part of this video on state transformers, what I'm going to do now is I'm just going to show you again the type class definition for the monads type class. And what I have here is this type class definition for monad, and I note that the kind for M at this point here is that M is something that takes in a concrete type and gives you back another concrete type. How do I know that? Because if I just look at this bind method, if I look at the bind method here, I know that each one of these must be a concrete type. Each one of these must be a concrete type. And I can easily assume that for B and for this A over here is that each one of these have a concrete type as well, and M, M is acting as a type constructor that takes in a concrete type and gives it back as an output another concrete type. Okay, so this is the kind for M here, and all it means is that if anything, if I want to create something, an instance of the monad's type class, I must ensure that whatever I pass in place of M, it must have the same kind signature as this over here. So in the last video, we looked at state T has the following kind signature, and it's obvious that the kind signature for M here and the kind signature for state T do not match. But what I can do is I can actually partially apply the type constructor state T by having state T S and M, where S over here is my star and M is this type constructor that takes in a concrete type and gives you another concrete type, and state T, S, M together it has a kind of star to a star. Okay, so what that means is that now if I would like to create something, an instance of the monad's type class, that something can be this piece over here. Okay, and and what we're going to do now is we're going to create an instance of the monad's type class, and in order to create that instance of the monad's type class, I'm going to first okay, so let's see this. Instance. Okay, so let's make this an instance here. So I'm going to have my code here. I'm just going to write some Haskell code here. So let's instance, and I'm going to put a constraint on my M. So the constraint on my M is that M must be a monad, and I'm going to have here monad, and I'm going to create state TSM, an instance of the monad type class. So let's provide here state T SM, where where I'm going to now provide the implementation to the bind method, and I'm going to provide the implementation to the return method. So again, just as a recap, this entire piece here, state TSM, this is in place of this entire thing is in place of this M here, because M and state TSM have the same kind signature. So just to make things a little bit clear, what I'm going to do is my return method, I'm just going to rewrite this as, instead of writing it as A, taking the first parameter of type A and giving it back some monadic value MA, I'm just going to write the type for return. I'm just going to write a type for return, but I'm going to replace everything that is an M with my state T as M. So A and M, instead of writing M there, I'm going to replace that with state T S M and A. There you go. So This piece is my concrete type. This entire piece again here is some concrete type there. Now, can I provide the implementation to this return method here? So let's just assume that my code in this tone of yellow is in Haskell here, and I might make some silly maybe syntactical errors, but again the point is to give you this some of this theoretical background, at least in state transformers, as to why the implementation are the way it is, and maybe at some point I might take this set of videos and just type it out in Haskell to show you even the actual working of this code here. Okay, so return. What does return do? How do you provide the implementation to the return method? So return takes in as my first parameter some value of this type A here. So let's just say return X. Okay, and what I mean by return X here is that what I have at this point is I have I have some value that's inside this variable x that has a type. It has a type of this area. Okay, so just to be consistent here, let's just know that the type for this x here is a. Okay, and this is going to be equal to some value. It's going to be some value that is going to be of type state t SMA. Okay, now how do I create a value? How do I create a value that has this following type here? In order to create a value that has a type of state t SMA, I'm just going to invoke my value constructor. I'm just going to invoke that value constructor there. So let's invoke that value constructor state t. Okay, and in the very first field, I must pass in some value. I must pass in some value that has a type. It has this following type there. Okay, now how do I pass in that? So what I really need here is some kind of a function. I need some kind of a function here that takes in as the first parameter some state s. Okay, some state s, and it's going to give you back as an output some monadic value, which is m, and I have this tuple here of a comma s here. Now I already know that this value that is inside this variable x already has a type of a. So just to complete this code here, I'm just going to say, first thing I'm going to say here is, let's just go ahead and create this tuple here. Okay, the very first value in the tuple needs to be some value of type a. I already have that value in my variable x. Okay, I already have the value in my variable x. I need this new state here. Okay, this new state s at this point. Okay, and that state s that I'm going to get back over here is my state s, which is right there. I just put my state in that, and then finally I need this monadic term here. So in order to get this entire thing as a monadic expression, I can finally say at this point, I can just say this as return on a tuple of x comma s and whatever m is. Okay, again assuming that whatever this m is, again go back to my earlier videos where we made a very clear distinction that if m happens to be a state monad or a list monad or a maybe monad or a writer monad or a reader monad, it is that implementation of return that we are invoking on that m. Whatever monad m is, that implementation of return is getting invoked at this point. Okay, and with that implementation, what I have now is that this entire piece here in blue. So let's just say this piece over here in blue, which is this entire piece at this point, is some value of type m a comma s. Okay, I know that this x has some type of a. The state s here is of some type s as well, and this entire piece here is a function. It's a function, so everything has been matched correctly, and I'm calling my value constructor state t on this entire piece here, which gives me back some value of type state t sma. Now, in the next video, we're going to explore this a little bit further by providing the implementation to the bind method.